Topic number 1. So this topic probably you need to know. Okay, what is calibration? What is traceability? All the terminology used in measurement. Okay, and measurement of uncertainty. Yeah? Basically, this is the topic. So maybe we will discuss about this. Okay, these are terminology used. What is accuracy in measurement? What is accuracy? So accuracy is something which instrument must obtain the true value. Okay, so maybe your reference value is this, or your true value is this. Okay, then how you ensure that how you know that your equipment is accurate? You need to measure. Okay, at least 10 data maybe. Okay, 10 data, same place, same condition, everything the same. Take 10 reading, okay, or 10 data, or 10 reading. Measure 10 times. Okay, then find the average. Average, you know how to calculate. So x1 plus x2 and so on up to xn divided by n, right? Average. Find the standard deviation. Standard deviation, you know how to calculate. The sum bracket, within bracket, first data minus the average, or average minus the data. I think it's okay because it's square, right? Square. Then divide by n minus 1. Use a calculator or use your spreadsheet to calculate. Okay? So you need to look at this value, average. Is the average close to the true value? If it's, then it is accurate. So accuracy of a measurement system is the degree of closeness of the measurement of a quantity, right? One quantity, to that of the quantity actual or true value. Is this okay? Precision is a bit different. Precision can be, we can use repeatability or reproducibility. Okay, repeatability is something which you need to use a standard deviation to analyze. Reproducibility, you need to have other method to analyze. Okay, we normally use a gauge R and R. Okay. So precision of measurement system also called repeatability or reproducibility. Okay, is the degree to which repeated measurement under unchanged conditions show the same result. Okay, so you need to understand this. So this is a true value, nothing to do with true value. Okay, normally repeatability, we will not talk about true value. Accuracy, then we will compare, right? True value. So repeatability is this. Okay, you just repeat the measurement. Okay, make sure same operator, same instrument, same operator, same environment, same condition. Okay, repeat it with a very short period of time. In one go, you take 10 reading or 20 reading in one go. Everything settled already, right? Okay, in one go you take 10 reading or 20 reading. Calculate the standard deviation. Clear? S value. So normally this is what one has to do. Okay. And then so normally it's first data minus the average, right? Square, right? Sum of all these. Okay, n minus 1. Standard deviation. So in some cases, the repeatability is in some brochure is 2s, so times 2. Okay, and then they state what is the value, right? 0.03 micron. So when you buy equipment, if they state this, then you can before you buy, okay, you need to check whether is it true or not. Yeah? But it's not easy lah, alright? Sometimes we miss out, okay? That they state repeatability, 2S, how they get, you need to query them, okay? How they get the repeatability. Okay, so hopefully the S or 2S should be small. Okay? Or 0, that is the best. All your reading the same, right? That means it's very good. Any question? Repeatability? Okay, so measurement of uncertainty. Very heavy topic, this one. Right? Very difficult topic. But never mind. Just follow the standard. Normally, when we want to calculate measurement of uncertainty of a measuring system, we always refer to SAC. Okay, Singapore Accreditation Council, whereby there's a guidebook, right? How to analyze your uncertainty. So follow that. Okay, so uncertainty of a measure, every must analyze. Follow this guide. Or follow this guide also can come. Okay, it's a standard. Guide for measurement of uncertainty. A lot of calculation, a lot of statistics. You have to understand. But if you don't understand, never mind. There are example for you to follow. You just follow, right? Related to the equipment that you or the measuring system that you want to analyze.
Okay.
So your customer would like to know normally what is the measurement of uncertainty. No measurement is perfect. After you measure, you need to analyze. Okay. It's just like I tell you, okay, this morning I give you some information, right? Okay, so you need to know what I say is correct or not. So you need to go and find out.
I just find the division here.
I show you the PowerPoint, right? Okay.
How you do that measure?
How you to go and
Just
attend,
here.
right? But if you want to know more, you need to attend to find out more. Okay? Maybe I give you the wrong timing also. And the wrong date. You better confirm. Okay, so this what I meant. So same thing, any measurement. How good is the measuring system? You need to find out.
I'll try.
Especially measurement is always a question. So uncertainty, there's always an uncertainty. Okay. So this is a measure. You need to analyze to get this value. It's a measure of the goodness. How good is your results? How good is the result? So just now I give you your paper back, right? Question mark, right? Question mark. I give 10 mark, right? Question mark. Don't know how good, huh? Is this the 10 mark? I judge, right? I do judgment. Sometimes I overjudge. I give you more mark. So if you are not sure, all right, my gauging, you send it to another assessor to mark. You get it? So the test. So never mind. In the exam, don't worry. I will give you more mark on normally. And then the mark addition, subtraction or whatever, sometimes I make mistake, right? But don't worry, somebody will check. We have a checker. Yeah, they will check all the mark. So there's a checker to check whether I key in correctly or not, to check whether I calculate correctly. So don't have to worry, right? Normally we will grade you higher one. All right, but do your part. That's important. Do your part. You need to study. If you don't study, of course, cannot lah. How to give you mark? Cannot. Okay, uncertainty is a measure of goodness of a result. So it's actually a parameter associated with the result, okay, of a measurement that categorize the dispersion of a value that could reasonably be expected. Okay, this word here, reasonably expected, that means true value, alright? So your uncertainty value is a range of value like this. Okay, it's a distribution or dispersion. Okay, this type of curve one. Okay, have a range of value, uncertainty. So you need to know this value, and hopefully your true value is inside here. Okay, and then when you use this range and your value, right, you have your value, okay, and then you have your uncertainty. Then you compare with your tolerance. Okay, upper limit is here, lower limit is here. Okay, so you don't use only this value that you obtain, measure value obtained, to decide whether in or out, because sometimes it's in a boundary. Okay, so question mark, right? Your question mark value is this. Okay, so your range is out of the your true value is here, but the range is out. So do you accept or reject? Uncertainty and measurement come in. Clear? If it's exactly in the center, okay lah, no problem. Your tolerance, then your range, uncertainty value, your value is here, no problem. But come to at the border, okay? Your value is this way. Then your uncertainty is this. So uncertainty value is used in this area, this type of case. Am I clear? Important, this one. In the research and development or whatever, medical or safety or commerce, okay? Or you do research, right? Scientific research. These are important things. You need to have this value. You need to analyze. Okay, any question? So when we analyze, we have made a lot of definition. What is type A? Uncertainty, right? What is type B? Uncertainty. So type A is here, type A. Okay. Type A is something that you can measure, right? The parameter, the quantity that you can measure. So that is type A. So type A uncertainty is the result expressed in a deviation evaluated by method of statistical analysis. Something that you can measure. Okay? The value that you want, you can measure. So that's type A. So you use normally average. Okay? You use standard deviation. Okay? Then with the standard deviation is uncertainty, one of the uncertainty value. Am I very clear? But your measuring system is not only based on this uncertainty based on this measurement, right, of your equipment, but you have temperature, right? This is your measurement, Okay, measurement equipment is like this, measurement a vernier caliper maybe, or micrometer you measure, right? Okay. So the measuring line of measurement is here, right? Okay, and then you have the scale. The scale is here. Okay, where you obtain the value. That's a very schematic view. Your workpiece, right? Is the temperature 20? Question mark, right? Question mark. Okay, so there's uncertainty value here. Uncertainty value here. Okay, then there's glass scale, the thermal expansion. Right, when it's 20.5, right, 20.5.
In your book or formula.
question mark,
Or
right?
is it
Temperature question mark. Then
something
you
about the
use the
magnification
coefficient of
or
expansion to
and
calculate
then like total E,
the
something like that.
temperature error. Okay, again, this value question mark. Okay, then you get your reading from here, glass gear, right? Is the glass gear 20? Alright, is the glass gear 20? Question mark.
Ask so much.
And
Yeah.
maybe your glass gear is 20.1. Okay, then you have to calculate the temperature error. Then you pick the coefficient of the glass gear. Again, question mark. This value you take a question mark because you cannot measure the coefficient of the glass gear. You cannot measure, right? The material, coefficient of the material. You get from somewhere, right? You get information from somewhere. Your temperature device, question mark. You cannot measure your device whether it's accurate or not. You send to somebody, right? For calibration, you get the value. This is, and then you include all this value. That is under type B. Because you cannot do yourself, you get information from somewhere. Am I very clear? So type B, uncertainty in the measurement result is expressed as a deviation evaluated by method other than the statistical analysis of series of observation, because you get from the certificate. Right, you send for your temperature sensor. But you have to calculate what? You have to calculate the error, right? You get from here the certificate of all the devices. Yeah? So that's under type B. Because you never get this data yourself or measure yourself. You get some from your historical value, from your engineering handbook, right? From your certificate, right? Your certificate must be don't anyhow pick any. Your certificate must be traceable one. Traceability is there. You cannot just send to any company, okay, and then get a certificate over my temperature uncertainty is this. No, you need to be. You send your device to an accredited laboratory to get it done. Okay, get it calibrated. So that's our whole idea. So if you don't know, never mind. Just use your knowledge. Search, okay, and then look at the example how they calculate. Okay,
Your book not.
you're educated enough.
You know the formula for difference in weight.
Okay, so that's about this topic. Any question?
Okay. You want to show me?
Then there are other parameters which I don't want to explain. Okay,
Things grow.
there are other parameters in this evaluation, expanded uncertainty. So please, if you want to be very good in this, okay, then look at my example. Go to SAC website. Alright, there's a guidebook. So take 100 over pages. Example is there. Okay, then you can learn more. Especially as an engineer in a company, you need to know how to analyze, okay, the measurement of uncertainty. Okay, any question? Then you have a coverage factor, effective degree of freedom. Then using your T distribution, find the coverage factor, degree of freedom. For degree of freedom from your T distribution, okay, you can get your coverage factor. The coverage factor times the combined uncertainty will give you the expanded uncertainty. That's sort of calculation we are talking about. Okay, but at least you must know all. At least you must know the definition. Some of this definition. Okay, so that's about topic 1. So topic 2 now. So any question to ask? No, very good, everybody prepared. So we are talking about precision. If you are talking about in the construction plus or minus 10 mm, don't talk about all this. Clear? We are talking about using part in the aerospace, using part in the engine. The tolerancing is very important. Okay? Because your measurement is 20 degrees Celsius, your engine after running, what is the temperature? Can be 1000 degree. So the tolerancing is very important. At 1000, your part are expanded already. If your tolerancing is no good, you think the part can work properly at 1000 degrees Celsius? Yeah, your aerospace engine, you just, okay, your car engine, right? When they manufacture, they measure at 20 degrees. But when you drive a car, your engine running at what temperature? Easily, few hundred, right? But how come it can run so smooth? It's the tolerancing engineer. Okay? So the Japanese is good, the American is good, okay? The French is good because many years of experience in designing engine. They know what is the tolerancing that to be used. Your drawing, when you draw, is 20 degrees Celsius. Clear? So you need to carry out a lot of research and development to produce good engine, good jet engine, good engine for your F1. So engineer very important, very important. Otherwise, your train won't break down. Because we don't have good engineer. That's why the train always break down. Okay. So error in precision measurement. Okay, so introduction. I don't want to talk about that. More important in this topic is the type of error. We are talking about type of error. So I suppose you should concentrate on the various type of error. What is alignment error? Okay. What is parallax error? What is temperature error? What is elastic deformation error? So I hope you have already done the revision. In the case of alignment error, we are talking about the scale. Okay? Is the scale in line with the line of measurement? Okay, the line that you're measuring is, and the scale is in line or not? Okay, so you'll be talking about some design of the instrument to minimize the alignment error. One of the principle is Abbe principle. Okay, if you strictly follow this alignment error, principle of alignment error, then or you design instrument based on this principle, then the error will be minimized. Okay? So it says that in this principle, it says that the line of measurement and the line of your standard must coincide. Okay? So this is your line that you're measuring. You got this is equipment that you measure. Okay, you obtain your this line reading. Okay, from a glass gear. So this is the glass gear. So make sure that this line and this line in line. Okay, it should not be offset. This is a line that you're measuring, okay? And the scale is somewhere else. Don't know where. Okay, maybe below or slightly below. Okay, so there's an offset. Okay, the line of the scale is here, and the line that you're measuring is here. Okay, or somewhere else. Then you got problem. Okay, so this is the offset. Okay. So you need to buy equipment depending upon the accuracy. Hopefully the scale and the line that you are measuring is in line. Okay. So an example of instrument that conform to this principle is this, right? Micrometer. The line that you are measuring is here. Okay, the line that the line of the scale or axis of the scale is here, so they are in line. So this type of instrument, the error will be minimized. Okay. But again, you need to know the force. Okay. So if you apply more force, of course, you will miss a line also, but it's minimized. But this type of instrument, vernier caliper, right? The line that you are measuring, your piece is here, right? The line that you are measuring from here to here, and the scale is here somewhere else. There's an offset. This type of instrument will never is an instrument that does not conform to Abbé principle, okay, or the principle of alignment. Then you need to be careful because any force will tilt, okay, and the error will be large. Any question? So you need to explain in this way. Okay, so this is a normal scale. Okay, then when we measure, you did not measure along the line of measurement, not parallel. Of course, you get alignment error, and this is why called cosine error. Okay, so the line that you obtain, the measurement that you obtain is here.
Really? You just copy out.
Okay, and you're supposed to get the true value here, right? The true value is along here. Okay, so if you know the angle, you can calculate the true value, right? So this is what's called cosine error, because you use cosine to find back this, okay, to find back the length that you're supposed to measure. Then you can find the error, okay? Find the error. So it can be a lot, right? 1 meter, 2 degree, okay? The error can be 0.6 mm. So the error is the true length minus of the length that you measure, okay, minus of the true length. Sorry, this is a true length, right? True length. This is a value that you obtain. Okay, so value that you obtain minus of the true length, that is the error. Okay, any question? You can use other instrument to explain about alignment. Then of course the next one will be parallax error. The parallax error is this. Occurred when the observer line of sight is not in line to the reading point. Make sure that you always read the line of sight must be perpendicular to the scale, right? Okay. And some of this scale, the vernier caliper, right? There's a step like this. So if you have read at the angle, can be one division different, 20 micron. So 20 micron will be your parallax error. So to avoid this, buy an instrument with a chamfer. The scale chamfer, right? So your scale will be very, your vernier scale will be very clear, very close to your main scale. Okay, so that's like this one, your micrometer, right? There's a chamfer. This design is better, okay? So the parallax error will be reduced. Do not give me example like this one. Some of them don't know where they get glass measuring flask. We are talking about measurement, not volume. Clear not? Then after that, there's a scale here, right? Yeah. Then they say there's, okay. So if you give me this type of answer, I will give you 0. Am I very clear? We are talking about dimensional. We are not talking about measuring volume of liquid.
Okay.
Although it is similar, right? But I don't accept
this
this.
center lah.
I never teach you how to measure water.
Draw
Right?
these two circle. Then after that,
Yeah.
just
I
measure
don't know thermal fluid or what you are
difference
studying.
in diameter.
Am I very clear?
2.5.
You must tell me the instrument that measure length one.
So difference in diameter and radius. Probably radius.
Okay, so I should we measured or calibrate die indicator always read perpendicular to the scale. Okay? Do not read at an angle, right? And in some high sensitive type of indicator for comparison, okay, buy something which is better, okay, to avoid this parallax error. One of the things is that the pointer must be very thin, okay, and the displacement between the pointer and the scale is very close. Then the error will be reduced. Another type of indicator, okay, for as a comparator, you can buy with a reflector. So this reflector, how you use? This is a pointer, right? Before you read, you look at the reflector. Any images here, any shadow. Clear? If there's no, that means your position is correct. Then you can take reading. So this is another way. Another means buy something which you can avoid. Okay, or you minimize the parallax error. Okay, any question? Then you need to read them, okay, and express.
Let me copy. Let me copy.
Okay, so I think I will go on to topic number 3.
那个 value 放个 value 啊，你要放 copy whatever 放在那个。
you need to draw.
Why?
This one. The one got the.
School track, right? School tracks.
哦，OK OK，你那边有一个。我麻烦你这个东西是吧？不如了。那么来，在那边有。那边有一个。
So if you look at the past year question,
From the middle of
normally
here.
we will
From
ask
the middle
you,
of this one.
okay,
Yeah, just all the line like that, all the line coincide like the same point kind of.
the definition, right? All the definition, I hope you can remember.
Seriously, don't know how to do it.
What is lead, what is pitch, right?
My quiz all fail one.
I good.
What is major
I don't like to
diameter,
do
what is
homework.
minor diameter?
My quiz all get less than 10 marks one. How often? If it goes with scripts.
I hope you can still remember this standard, how to get the value from the table and calculate the clearance.